you, kid. Yeah, you. You want to buy some tool bits?
What?
Yeah, I got the best stuff. Look at this. We got HSS. We got Brazed on. We got inserts. I got it all. Best stuff.
You got any ceramic inserts?
Whoa, kid. You want to get me sent to the big house or what?
You mean a CNC shop?
You ain't so innocent, are you, kid?
Hey, aren't you that old, Donnie?
Shh. Hey, come on, kid. Guys gotta make a living. Don here in Florida, and I'm doing this video mainly for guys that are just starting out, that are learning their way around the lathe and are always kind of up in the air about what cutting tool to use. And this can be a little bit difficult to decipher, especially when there's so much information out there on the internet and on YouTube. And there's a lot of guys that do really good stuff, but a lot of it's going to just be over your head. So if you really want to know what the best cutting tool is for your small lathe, your Atlas, your Craftsman, Southbend, Logan, stick around. We're going to talk about that, and I will tell you what the best cutting tool for your lathe is going to be. Okay, so let's get started. Okay, you're going to see a lot of videos on how to grind and prepare high-speed steel for your lathe, and it may be this size, or it may be this size, or it may be this size, and more than likely, if you're just doing light work, it's going to be this size on your smaller lathe, your Southbend, your Logan, your Atlas. So this size, yeah. This size, no. So we'll put that aside. These high-speed steel bits, if you want to know the truth, I don't use them unless it's for something special. Okay, let's say I need to make a forming tool, something like this, or like this for grooving. Then I'll go to high-speed steel if I don't have something quickly available in carbide. And I think I just gave it away where I'm headed. You should never rule out high-speed steel though, because you can always make tools that you don't have. And when I was in high school in machine shop, it seemed to me that we spent more time grinding high-speed steel than we actually did on the lathe. And that was a little off-putting for a 14 or 15-year-old. It got tired really quick, and when I started working in shops, I didn't usually mess around with high-speed steel. I'd just find another bit that somebody had already ground, and I would just regrind it or sharpen it and press on. I would always avoid grinding these if I could. And as I got older, I found other ways to speed up the process of setting up high-speed steel bits, and you can call it cheating, but let me show you. For example, grinding something like this for contour, say you want to make a ball or a round socket in the end of a piece, I don't try to grind that out. I'll simply take a carbide mill, and I will just cut the angle that I need. And what I'll do is, when I set this up in the milling machine, I'll set my relief at about 7 degrees back, 5 to 7 degrees back. So when I come in like this, I'm already taking out my 5 to 7 degrees. And then I can quickly clean it up with a diamond bit to get my relief this direction, going back this way. So I have a 5 to 7 degree relief all the way around like this. And it doesn't matter if it's something small like that or something large like this. You can actually see where I used a diamond bit to make my relief back in here once the form was made. So that's one way to cheat the system. Another way to cheat the system is this. If you haven't already built or made one of these, it's simpler just to cut the feature you want onto the piece. Say I wanted to make a cutoff tool out of this. I could just simply go like that. I would have a grooving or a cutoff tool, or if I wanted to make I could lay my fishtail up on here like this and mark out what I wanted, and then simply cut that off. And then once you cut the desired feature you want, you just go over to the grinder, put your relief in, and basically you're done. So yes, high-speed steel you can use, but they are time consuming and you have to have a certain amount of patience. My suggestion is, if you want to get started in high-speed steel, don't start with blanks. Go out and buy yourself a kit, and this one here, everything's already pre-ground, so once you start using it, you simply just have to maintain the features on the grinder as you sharpen it. That's all there is really to this here. And see, you have different features on these, and these are really handy. Honestly, I just bought these on a fluke. I was at the flea market and the guy had these for $2.50, and they've come in handy from time to time. I don't use them often, but they're always nice to have. It's always good to have more tools in your toolbox. So that's my honest suggestion. Save yourself the agony of grinding. You know, I did it when I was in high school, and I will do it occasionally, but honestly, they take a lot of time. Unless the payback for you is just gaining another skill set, then probably this is going to be the way to go. And you can always work back up to something like that. That's never an issue. You can always come back and learn that skill set. But if you want to get going and moving on the lathe, start with something like this. But this isn't my favorite, nor is it what I would suggest. Brazed carbide. I really never spent much time with brazed carbide. Like I said, when I started off, we were just basically regrinding other people's tools because I was always working on shared equipment. Nothing of my own. It was, you know, whatever the guy left there, that's what we'd resharpen, that's what we'd use. Later in my career, I went into the military, and in the military, everything we used at the sites that I was at was insert tooling, and that's mainly because it's much easier for the military to ship you 1,000 inserts than it is 1,000 tools. They're not cheaper, but for the military this made sense because anytime you move something from point A to point B, it costs money, so you had to take the lowest amount of weight possible to get the most amount of stuff into a cargo plane. So yeah, insert tooling is what I used almost my whole life. As I got older and got away from the military, I started running into brazed carbide, and you can buy this stuff already pre-brazed. There are some guys on YouTube that'll show you how to braze carbide onto tooling. Honestly, I've never done it, nor will I probably ever do it, because it is time consuming. Maybe when I'm retired and I have the time, I'll do it. But for me right now, just buying it pre-brazed and using it is fine. I'll just buy it, resharpen it as needed, and press on. That's the beauty of the brazed on carbide. Some people will tell you can't form brazed carbide, but I beg to differ. These were all tools that were taken from original brazed on carbide like this and reformed to do specific things. This one in particular has been cut out with a chip breaker in it. So that's pretty cool here. So all these were actually recut to do something specific. So you can, if you have diamond or a diamond wheel, you can recut brazed carbide to do something specific. But yeah, this is where we start. For me, I don't go out and buy brazed carbide new. I think I've only bought maybe half a dozen brazed carbide tools. Mainly, I'll just pick these up used at the flea market and resharpen them. If you've seen my homemade diamond hone machine video, that's really brought these into a whole new perspective, because now I just don't dull them and let them sit in the box and hope to take them to work someday and sharpen them. So let me show you that real quick. Okay, so this is the machine in question. Since I built it, since that last video, I put another diamond wheel on here. I have a whole bunch of these like this that go on the 1/4 inch shank. So that I found is really good for setting in chip breakers. You can just come in like this, grind out your own chip breaker as needed into carbide, which is nice. Let me show you how quickly you can re-hone carbide with diamond. And this is a crappy $6 wheel, by the way. I plan on upgrading this at some point in the near future. So, but just with this, let me show you how well this works. And that's it, it's sharp. That didn't take any time at all. If I'd have been on the green wheel over there, I'd have probably been 5 minutes to do the same thing. That diamond just cuts it like that. And since I've built this machine, brazed on carbide, no problem. Okay, finally we get to insert tooling, and I'm sure you've seen plenty on insert tooling. This is probably a good size for the Craftsman, Southbend, Logan lathe. And the nice thing about insert tooling is, as long as you stay in the same tool holder, when you change from one to the next, you don't have to set your tool height again. Everything's right where you left it. And same as if the end dulls here, you just loosen it, turn it around, use another end, and you don't have to reset the tool height or anything. Everything is still to dimension. I think where things start to get tricky for guys with insert tooling is this. One is the cost. These little inserts here, one of these inserts by itself costs more than your brazed on tool. I can buy one of those brazed on tools over there, flea market, for $2 a piece, or you can buy them online for $4.50, $5 a piece. One of these inserts here could run you $8, $10, $12 easily. So it will get expensive if you start using inserts regularly. Another area where people tend to get messed up with these inserts is the nomenclature. And if you do decide you want to go with inserts, you might want to get yourself an engineer's black book, because this is one of the guides that has all the information about your insert tooling in it, okay? There are others, of course, but this is just a handy little reference that you can keep in your toolbox. And what you really have to look for, I mean, there's all these different insert shapes here, and I tend to stick with this size here, the 60-degree rhombic, but I call it a C because they usually start with CC. For example, CCMT starts with C, and I think of the C as cuadrado in Spanish. And the D, I like the D, the rhombic, the 55. That's pretty handy too for getting in tight spaces. That's just the nomenclature for the shape. It's this one here, number 2, that'll get you in trouble. This shows your relief angle, number 2. And this one right here, N, on a small lathe, you want to stay away from that, because that's 0 degrees relief angle. This would basically be what we call a neutral or negative relief angle. And the problem with this is that it eats up a lot of power. And your smaller lathes, you're already dealing with maybe half, 3/4, maybe 1 horsepower. And you're going to burn up a lot of power trying to push through a tool like this. You're better off staying with a 7-degree relief angle. So anything that you get in tooling, the second letter should be C. I would suggest that anyway. This will allow your machine to operate as if you had a positive rake, which it is definitely easier on the machine, and it's easier to push through. So just kind of keep that in mind. And of course, this is just a tolerance letter, and this is your chip breaker down here. So tolerance and chip breaker. These first two, shape, relief angle, always stay away from the ends, tolerance, and chip breaker. And with this little guide right here, you'll be able to easily see what you're getting. So the question is, pick your poison. Are we going to spend a little bit more and have the convenience of insert tooling? Do we want to use brazed carbide, which is cheap but can cut through just about anything and is sharp? Or do we want to fool around with high-speed steel? And all of these have their advantages. High-speed steel, these very nice finishes. You can basically contour it to anything you want. The brazed carbide is cheap and will cut just about anything at any time, and is easy to take care of if you have the right tool. And then again, there's inserts, which is expensive but convenient. For me, having used all three of these, I can say this: each one has their place and each one has an application. I couldn't do without any of these. I use all of them. The ones I use the most are these though. When you start out, you're probably going to be looking at something like this though. This is be an AR or an AL tool, and these are very common for just general cutting. But me personally, this is what I prefer right here. This is a GR, and they also make a GL, and the R and the L just signify right hand or left hand. And I like this tool a lot, even though it doesn't give me the close-in tight rigidity that this AR might give me. It's very nice for working up close to your chuck or your collet. As you can see past everything, you can see what's going on, and it gets that bit out there a little bit more. So it's just a really nice, easy bit to work with. When you watch me on the Craftsman, probably 95% of the time that you'll see me on these YouTube videos, or if you come in and watch me in the garage here at any given point, this is the bit that I'll have in there. This is the one tool that I'll have in there, because I can face with this, I can cut with this, I can chamfer with this. You can see me in the video on the ER32 collet tool. When I did that video, you can see me actually cut taper angles by hand with this tool. This is a very, very handy tool. And it doesn't mean I use this 100% of the time, but it is my favorite tool. So in the end, when it comes to tooling, my suggestion is this. Start with what you're comfortable with and experiment and try different things. In the end, you'll probably come out with a tool that actually works best for you, and that will be your best tool. Again, don't go out and spend gobs of money on tooling. I would definitely maybe hit up flea markets and stuff like that and see what's available out there and experiment around a little bit before you go investing it into any big sets or anything like that. So I hope this is helpful for y'all, and good luck with your lathe work. And as always, from Florida, Don out.